Okay, logarithms. This is going to be only for the ACT, okay? Now remember with the ACT, there is nothing on there that technically needs a calculator. So what that means is if you're used to finding logarithms with your calculator, you may not be able to do it. I've noticed a lot of questions are going to ask you things in such a way that you won't be able to use your calculator. I'm not saying the logarithm problems are hard. They're actually not. And I'm not going to go that deep into logarithms. But we do kind of need to make sure you understand them like at a foundational level. Okay, so the logarithms are a way to isolate out and understand and look at in a different way powers, right? Okay, so if I have x to the y equals z, I can rearrange this to say that the logarithm base x of z is equal to y. Now I kind of think about this as a velociraptor talon. Okay, so like this is 0.1, this is 0.2, and this is 0.3. All right, so then we can say that the log of x of z is equal to y. Okay, I would recommend that if you come across a log problem, there's usually one. I think I've seen an ACT test that had two of them. You just start by rearranging it as an exponent. Okay, so let's talk about that for a little bit. Like, let's say we have log to the base 2 of 4. Now you may be able to quickly see this as 2, which it is, but if you're not that familiar with logarithms, then what I want you to do is I want you to draw an equal sign and do x. Draw your velociraptor talon and then do 2 to the x is equal to 4, and then you're like, oh, that's right, it's 2. Now you can figure this out on your calculator, but I found most of the time when you have to find a logarithm, it's going to be something that you can just work out in your head. Okay, I mean, in some way or another. All right, now I'm not going to go into why it is, but I'm going to show you real fast how you would do this on your calculator. So this would be the same thing as log to the base 10 of, let's see, 4 over log to the base 10 of 2. Actually, I hope I got that right. Okay, let's see if that's true. Let's check it out. Never mind, the logarithms. So 4 log divided by 2 log. Yep, that's correct. Okay, now you may have noticed when I did my calculator, I didn't write the 10 there. So when you don't have any number there, it means 10. When we're talking about bases, we literally mean that we operate in base 10. Okay. Let me kind of show you why that is. Now this question I actually saw on a test that was in the ACT. Now remember, the ACT will never, there's a reason this doesn't work on the ACT. I can't remember what it is. Well, here, I'll show you. You won't see this on the ACT, but I saw this question on, I think it was another exam. I teach a lot of standardized tests, and this one was an Italian exam, and I just thought this question really kind of drove home why it's base 10. Okay, so let's say we have log, oh, I remember why. why it can't be done the ACT is because you just stick in your calculator and you find the answer, and they wanted you kind of work through it. So it was a test that had logarithms on it, but wouldn't let you have your calculator. So the SAT has a section that doesn't have the calculator, but no logarithms, and the ACT has logarithms, but you can always use your calculator. So it wasn't either of those tests. It was a test that had logarithms that you couldn't use your calculator. So let me show you this question. All right. So they're going to ask you, the question was, is this going to be, is x going to be greater than 0 or less than 1? Less than 1, greater than 1, less than 2, greater than 2, less than 3, A, B, C, D, greater than 3, less than 4. Okay, so let's go ahead and rearrange this with our velociraptor talon. So 10 to the x is equal to 1,357. All right, so let's check it. Okay, so 10 to the 0 is 1. 10 to the first is 10. Is 1357 between 1 and 10? No. 10 squared is 100. Is 1357 between 10 and 100? No. 10 cubed is going to be 1,000. Is 1357 between 100 and 1,000? No. 10 to the fourth will be 10,000. Is 1357 between 1,000 and 10,000? Yes. So you can see here that when you have log base 10, whatever this is, it's not going to be a whole number. I mean, it could, but it's going to be the number you would use if you put this into scientific notation. So 1357 is going to be 1.357 times 10 to the third, right? So the logarithm of 1357 will be some number between 3 and 4. Okay, does that kind of make sense? So let's check it. Let's just see what happens in our calculator. Okay. 3.13. Now let me just take this number. Let's go ahead and get pretty sensitive here. I'm going to do 10 to the power of, oops, that's not what I wanted. I'm going to do 10 to the, what is, oh, I know, you do this. Okay, so clear. 10 to the 1357. See how that works? 10 to the 3.1325, whatever, will approximately be 1,357. Logarithms. So sometimes the logarithm question will kind of show up in another question that has to do with scientific notation. I've seen that before. But more often than not, it's just basically some exploitation of what we already know about powers. So you might see a problem like this. Solve for D. Solve for D. Okay, well, that looks pretty spicy, huh? So let's go ahead and rearrange this with our velociraptor talon trick. So we're going to have pi minus d to the 5 minus d power is equal to 1. We'll just think about powers. Anything to the 0 power is 1. Okay, so in order for this to work, 5 minus d has to be 0. So therefore d is 5. This was spicy because this part literally didn't matter. See how that works? Classic ACT. Classic ACT. Okay. So, okay, so, if you don't have any base written, then it's base 10. If you see this, ln of something, let's see, ln of, I don't know, 5. This is the natural log. So ln is the same thing as log to the base e, Euler's number. Okay, now, or the growth constant. E shows up in a lot of things, and of course it also shows up in logarithms and is very important to logarithms. For your purposes, you don't need to worry about E or what the natural log is, but I just want you to know that if you see ln, that is the same thing as log to the base E. Okay, so if you have ln of 0, ln of 1 is equal to 5 minus d, solve for d. D is still going to be 5, okay, because e to the 5 minus d has to be 1, so 5 minus d still has to be 0. So don't get too stressed out if you see ln. I've seen ln, but it was still the same type of problem as this, okay? The logarithms on the ACT are not that deep. They're just not that deep, okay? So if you come across one and you don't quite know what to do, work it, look at the answers, and then once you get it wrong, that's fine, you get it wrong, but then go back and figure it out. It's usually going to be something clever or like a logic trick question, but not necessarily like you have to go take a whole logarithm section in pre-calculus. You don't. If you haven't learned logarithms, I've just told you everything you need to know for the ACT. Like a lot of things on standardized tests, the logarithms, the logarithm questions are foundational. They're not like that advanced. They're foundational, but they're not advanced. Okay? Great.